Welcome to today's segment of Further Mathematics. We'll be talking about the tangent and normal to curve at a given point. Now let's take, for instance, if we have a curve of this nature, let's generate the x and the y axis of this nature. This is the x axis and this is the y axis. Now, in getting the gradient of this curve, it's not possible to get the gradient of the total curve. So if the gradient of this curve is being requested, what you just need to do is to draw a normal to touch the curve, a straight line at any given point. You can choose this point, you can decide to choose here, you can choose here, but just draw a straight line that will touch the curve. Let's say call this point P. Now the gradient of the tangent is equals the gradient of the curve. So you want to get the gradient of this curve, just get the gradient of this line. This line is called tangent. So whatever thing you have as a gradient of this tangent is a gradient of the curve. An equation of tangent of a line is given as y minus y1 is equals m in bracket x minus x1. Now this is equation where m is a slope, or where m is a gradient of a line, y1 x1 is a point. So if this is a point, let's say your line is like this, this is your x1, and like this becomes y1. Then in this same curve, if a perpendicular runs from here, you know perpendicular means a line that creates 90 degrees to the given line. The slope, the only difference is that the slope, let's say this is m. Now the slope of the perpendicular, which is m1, if you multiply it with the slope of this, it should give you -1. So the only difference is difference in slope, because the two lines touch at the same point. So your x1 and x2 is still the same. You have your yx, but the difference is slope. Since this one is coming this direction, if you can get the slope, then you want to get the slope of this other one, you divide it by -1. So the slope of m, let's say the slope of this m1 that happened to be this other line, will now be equals -1 over m. You know how we got it? By dividing here by m, and you divide here by m, so that your m goes with m. So your m1 is equal to -1 over m. That's how to get the slope of the line. Now with this, you can always calculate the tangent and the normal to a given curve at any given point in time. This is just the basic relationship that you need to know, and this is the equation of tangent. Now I want us to try a question in applying this same concept. Let's say, for example, we have let's call this example 1. Now find the equation of tangent and the normal to the curve. Now this is a curve. Equation of the curve at point x equals 1. Now remember, the equation of tangent is y minus y1 equals to m in bracket x minus x1. This is the equation. Now let's get the value of our m. Remember, the value of our m is the gradient, and gradient is equals dy dx. That differentiating this with respect to x which is equals, if you differentiate this, remember the formula for dy dx is n x to the power n minus 1. So let's apply it here. You now have 6x squared minus 2x plus 3. So at point where x is equal to 1, you apply it by putting x as 1. 6 in bracket 1 square minus 2, you put 1 plus 3, and your answer will now be equals 7. So the value of your m is equal to 7. Now this is what you have for m. Now remember, we need to get the value of y when x is 1. So y is equal to, we are going back to our original equation, y is equals to, our x is 1 minus 3 minus 1 square plus 3 1 plus 1, which is equals to, there is 2, 1 is 3 plus this 4, that is 5 minus plus 1, 4 plus 1, 5. So the value of y is 5. Now substituting it into this equation, we now have y minus 5, because our y1 now is 5. What we calculated was y1, and this is our x1. So minus 5 to be equals, the slope is 7. We got 7 in bracket x minus our x1 is what? 1. You cover it, so which is therefore y minus 5 should be equals, when you clear off the bracket, x times 7, 7x minus 7 times 1 is 7. So we now have y to be equals 7x, this one should come to this side, minus 7 plus 5. So y is equals 7x minus 2. Now this is the equation of tangent to the curve. Now remember, the value of our slope is 7. Now let's continue. And the relationship between slope of a tangent and slope of the normal is m1 equals minus 1. So since we have 7, so our value of the slope for this will now be minus 1 over 7. If you divide, that's what you have. So our new slope, so the equation of our normal will now be y minus 5, which is still equals to minus 1 over 7 in bracket x minus 1, which is the same thing as y minus 5 then minus x, okay, equal to minus x plus 1 over 7. So multiplying this other side by 7, we have 7y minus 35 is equals minus x plus 1. So this is now equivalent to 7y minus 35. This crosses over to this side, becomes plus x, and this comes to this side, becomes minus 1 cos 0. So 7y plus x minus 35 minus 1 is minus 36 equals 0. So this is now our equation of tangent to this same expression. Now I would like us to move further in this same aspect. Now let's try attending to this question. Now with this, what we have here is, I told you the last time, the first thing we need to do is to get the gradient, and the gradient is dy dx, which is if you differentiate this, you have 6x squared plus 6x minus 2 Now fixing the value of x, which is 1, you now have this is 6 plus 6 is 12 minus 2. So the value of our gradient is 10. Now let's go straight into fixing the equation of the normal of the gradient. X minus, they said y is what? 0, and is equal to, here is 10, x minus 1. So y will now be equal to 10 x minus 10. This is the equation of the tangent. Now if you want us to go ahead solving the equation of the normal to the tangent, we'll now apply the same thing, but this time m1 will be equals minus 1, and we got the value of our m1 to be 10, so our m will be equals minus 1 over 10. So equation of the tangent will now be minus 0, which is 1 minus 1 over 10 in bracket x minus 1. You cover it. So this is equivalent to 10y equal to minus 1 times x is minus x minus 1 times minus 1 is plus 1. So take everything this other direction. You have 10y plus x is equal to 1, and this happens to be the equation to the normal. So I hope you actually enjoyed the analysis that just took place. Now, to refresh your memory on what we've just discussed, take the test that you're seeing now on the screen. Thanks. See you in our next class. Thank you.